content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight, I will be addressing several questions submitted by professionals and clients across the electrical industry, including electrical contractors, general contractors, business owners, and homeowners. These questions come directly from recent job inspections, project reviews, and they reflect real-world challenges encountered during construction and renovation projects. Asking the right questions before or during a project is critical. It helps identify potential issues early, prevents costly delays, and ensures compliance with safety standards. Open communication improves understanding, it strengthens problem solving, and promotes practical, effective solutions. I am committed to helping people better understand the electrical systems. Over the years, I have seen how valuable it is when clients take an active role in their projects. That engagement leads to safer outcomes and better results across the board. Homeowners and property owners never hesitate to ask questions about electrical safety, code compliance, or system maintenance. My goal is to simplify complex concepts and help guide you safely through this ever-evolving field. Now let's get into your questions. Junction boxes on ceiling grid wires. We are working in an existing office space where 120-volt junction boxes are attached to ceiling support wires. Is this code compliant? In most cases, this is a code violation. However, pre-existing conditions will be taken into consideration. If the ceiling has not been disturbed and your scope of work did not involve that installation, you are typically not responsible for pre-existing conditions. If you did not physically add a new circuit to a junction box, you are not typically responsible. However, if a pre-existing condition presents a severe electrical safety concern, the issues must be rectified. More to come on pre-existing conditions. That said, here's why this installation fails. You would need independent support wires required by the National Electrical Code, Article 314.23. Electrical box must be securely supported by building structure, not the ceiling grid. Ceiling wires are not load rated. They are designed for ceiling tiles and grids, not electrical equipment. National Electrical Code 300.11a. Junction boxes are a part of the electrical system and are prohibited. Support from ceiling wires unless specifically listed for that. Safety risks. Improper support can lead to loose connections, strain on the conductors, and fire hazards, especially in plenum ceilings. The correct method: support the junction box from a structure member or use a listed support system. When it comes to addressing electrical safety concerns during renovation and interior finish projects, it is essential to correct any serious hazards, especially when the pre-existing conditions pose a risk. One of the most common situations arise when ceiling covers are removed or replaced. Once that ceiling is open, everything above it becomes a subject to current electrical requirements. At that point, unsafe or non-compliance conditions can no longer be ignored. They must be addressed. Now, if the ceiling remains intact and a contractor is simply installing laid-in light fixtures, their responsibility is typically limited to their defined scope of work. However, if significant National Electrical Code violations are discovered above the ceiling, even outside of the scope of work, a field correction notice will be addressed to the owner. In most cases, the general contractor becomes responsible because the project cannot move forward until these violations are resolved. This is where we often hear pushback. The electrical contractor may argue, "That's not in my contract. Demolition of existing electrical components was not included. Another contractor is responsible for that." They often say that. And while these points may be valid contractually, they do not override safety or code compliant requirements. The reality is this: if the condition is exposed and presents a hazard, it must be corrected before the project can proceed. The best course of action is to avoid these situations during the bidding phase. Estimators and project managers should make every effort to understand what exists above the ceiling before submitting bids. That may include site visits, exploratory inspections, or asking the right questions up front. Because once the ceiling is open, there are no surprises, only responsibilities. Next question: what are my alternatives for grounding a detached permanent structure when there is no way to get a water ground to the structure? Let's talk about a situation that often causes confusion in the field: grounding requirements for detached services where no water pipe ground is available. This commonly applies to installations such as subdivision monument signs, traffic or utility service meters, permanent seasonal structures, other standalone electrical installations. When it's not possible to connect a metal underground water pipe at the main structure, the NEC is very clear. You do not have to force that connection. Instead, you must establish a grounding electrode system at the detached structure itself. Here are your compliant alternatives. Acceptable grounding methods for a detached structure: Article 250.50 and Article 250.52. You are required to use any grounding electrode that are present, and if none exists, you must install one or more of the following. A ground rod, most common. Install a ground rod, typically 8 feet driven. Second solution: concrete encased electrode, or UFER ground. If the structure has a footing or foundation with encased rebar, must be at least 20 feet of half-inch rebar or equivalent. Conductors in the concrete. A bare conductor, number 2, buried around the structure. You are not required to install a water pipe electrode if one does not exist. You cannot substitute a missing required electrode if it was available and if it was ignored. The goal is to establish a complete grounding electrode system at the structure being served. In most real-world installations where no water ground is available, the solution ends up being, with the authority having jurisdiction permission, to drive 2 ground rods. The final takeaway from this: if a water ground isn't accessible, you are not stuck. You are simply required to build a compliant grounding system where you, in many areas, including my jurisdiction, the authority having jurisdiction may evaluate grounding methods on a case-by-case basis, depending on the site condition, the soil composition, and the type of structure being served. And, as always, check with your AHJ because soil conditions, structure types, and local amendments can influence what is accepted in your jurisdiction. As I mentioned earlier, this brings up another common issue involving the grounding electrode system, specifically the main water grounding electrode conductor that's coming from the existing main structure. This is a situation that I see far too often. We're working on a residential or a commercial renovation, and as part of that project, a detached structure is being added. The electrical service is relocated from the existing building to the new detached structure. As part of that process, trenching is performed to run conduits between the original structure and the new one. At that point, you have a critical requirement. When the service is moved to the detached structure, the grounding electrode system must be established at the new service location. That includes extending the water grounding electrode conductor from the original building to the first means of disconnect, which is now located at the detached structure. And here's where mistakes happen. Contractors complete the trench, install the conduits, pull their feeder conductors, and forget to pull the water grounding electrode conductor while everything is open and accessible. Later, the question comes up, can we just install 2 ground rods? No. If you had the opportunity to install the grounding electrode, the water grounding electrode conductor during the initial trenching and feeder installation, then it was required to be done at that time. Missing that step doesn't eliminate the requirements, it creates a correction. This comes back to planning and understanding the full scope of work, not just the power distribution, but the grounding system as a whole. Next question. Can you add a bidet or heated floor to an existing bathroom circuit? We'll start with the bidet. It is possible with the right conditions. Most bathrooms are required to have 20 amp branch circuit dedicated to the bathroom receptacles. If that circuit only serves one bathroom, you may be able to add a bidet. The receptacle must be GFCI protected and AFCI protected where applicable. You must verify the load does not exceed the circuit capacity. Now, here is a possible issue with installing a bidet on an existing circuit, especially with the heating and dryer mode models. Draws 10 to 15 amps, depending on the manufacturer. That can easily lead to a nuisance tripping, overloading when used with hair dryers, curling irons. The best solution would be to install a dedicated 20 amp, 15. You can use a 15 or 20 amp receptacle for the bidet. Now on to the heated floor. The heated floor system. A heated floor system, no. Heated floor cannot terminate on an existing circuit. Electric floor heating systems are considered a continuous load. National Electrical Code 424, they run for an extended period of 3 hours or more. They must be sized at 125% of the load. Often draw significant amperage depending on the square footage. Because of this, they almost always require a dedicated circuit per manufacturer. Most manufacturers required it for warranty and proper operation. Standard approach: a dedicated circuit, a GFCI protection, and a proper load calculation per manufacturer's spec. The manufacturer's instructions are enforceable under Article 110.3b. During renovations or new construction, installing a dedicated circuit at this stage is the smartest move. Next question. I am in the process of selling my property, and the buyer's insurance company has issued a demand requiring me to replace my Federal Pacific service panel. Is it legal for an insurance company to require replacements of a perfectly good Federal Pacific panel? Yes, this is completely legal and very common. Insurance companies are private entities. Insurance companies set their own strict standards. Insurance companies can deny or condition coverage. This is not because of the NEC. It's about risk. The Federal Pacific panels are widely considered a fire hazard due to breaker issues. Without insurance, most buyers cannot close, so replacement or negotiation is usually necessary. The next question. My company was awarded the electrical contract for a project. The owner decided to purchase the electrical equipment separately from the contract. Upon arrival at the job site, the electrical equipment was not listed by a nationally recognized testing laboratory. As the electrical contractor, we expressed concern to the electrical inspector that we did not purchase the equipment. I am seeking clarification on why I am held responsible for this situation. Unfortunately, we're running into this more common, and it is frustrating. The reality of the electrical contracting. The responsibility falls on the installer, which is the electrical contractor, not the purchaser. Here's the clear breakdown of why you are responsible, even when the owner bought the equipment. The National Electrical Code requirements applies to the installer under National Electrical Code 100.2 approval. The equipment must be acceptable to the authority having jurisdiction. Article 110.3, the examination, identification, and installation and use equipment must be listed and labeled typically by a nationally recognized testing laboratory, like, example, UL. If it's not listed, it is not automatically acceptable, regardless of who purchased it. The authority having jurisdiction holds the license holder accountable. The authority having jurisdiction does not regulate the owner's purchasing decision. They regulate the electrical installation. The permit is issued to you, the contractor. Therefore, you are legally responsible for code-compliant installations. The inspector's enforcement authority is directed at the work performed under your permit. From the authority having jurisdiction perspective, we did not approve a purchase. We approve your installation. Installation equals acceptance of equipment. Once you install owner-furnished equipment, you are effectively certifying that it meets the code. You are assuming liability for the safety, the compliance, and the workmanship. Even if you verbally object, installing it anyway signals acceptance. Why? We didn't buy it, doesn't hold up. Because code enforcement is not based on procurement, it's based on installation and compliance. Think of it this way. The owner buys it, that's their choice. You install it, it's your choice and your responsibility. The best course of action would be to immediately write a notification to the owner, citing Article 110.2 and .3 explain the listing requirements or the need for a field evaluation. Coordinate with the authority having jurisdiction early. Ask if a field evaluation is required. Document everything, emails, RFIs, site reports, and refuse the installation if necessary. This is often the only way to fully protect yourself from a failed inspection, liability exposure, and rework costs. Next question. Pull chain versus wall switch. The inspector rejected my work because I installed a pull chain switch instead of a wall-mounted switch. The inspector indicated that a wall-mount switch properly wired to the premise wiring is mandated by code or standards. Why does this distinction carry significance in this context? The inspector isn't being picky here. This is about meeting the intent of the required lighting controls for safety and usability, not just having any switch. Why the pull chain was rejected under the National Electrical Code, Article 210.70A1. A wall switch control lighting outlet is required. It must be located at the usual point of entry to the room. The key issue, the control location and accessibility. A pull chain lighting outlet is integral to the luminaire. A pull chain is not part of the premise wiring system. A pull chain requires a person to enter the space before activating the light. This last point is the deal breaker. With a pull chain, you may have to walk into a dark room. This will increase the risk of trips and falls, contact with hazards, and unsafe navigation, especially in the basement, attic, storage rooms where it's dark. With a wall mount switch, the lighting is immediately accessible upon entry. The space is illuminated before you step fully inside. The requirement is about safe egress and entry, not convenience. Why a fixture switch doesn't count even if a pull chain does control the light. It fails because it is not a wall switch, it is not located at the required control point, and it does not satisfy the definition of switching means connected to the premise wiring. The bottom line, a pull chain controls a light, a wall switch provides a safe control of a space. That distinction is exactly why your installation did not pass. So the best course of action, always install a wall-mounted switch at the point of entry. You can still have a pull chain in addition, but not as the sole control. Next question. Permit for a residential elevator. Next question. I was contracted to build an elevator in a custom home. Have an elevator permit from the elevator company. The inspector has requested an electrical permit. Am I required to have both? Yes. You should expect to pull an electrical permit for a residential elevator. And in many jurisdictions, it may even involve multiple permits and inspections. Why a permit is required? Under the National Electrical Code, elevators fall under Article 620, which governs elevators, dumbwaiters, platform lifts, stairway. These systems are not typical branch circuits. They are specialized, code-intensive installation tied to safety and reliability. How the authority having jurisdiction views it. In my municipality, the authority having jurisdiction typically requires a permit because elevators are considered life safety equipment. They involve dedicated circuits, disconnected means, and emergency operation requirements. An electrical permit is required because, as the electrical contractor, often a separate elevator permit is required in many jurisdictions. A separate permit for the elevator system itself as a building permit, mechanical, or a plumbing permit, typically pulled by the licensed elevator contractor. This may fall under the state elevator inspection programs, a third-party inspection agency, or a multi-trade coordination. Just remember, you cannot skip an elevator inspection even in a custom home. Because the system is permanently installed, it connects to the premise wiring, it introduces unique hazards if improperly installed. That automatically triggers permitting and inspection requirements. The best course of action: contact the authority having jurisdiction early to confirm what type of permits are required, the scope of your work responsibility versus the elevator contractor. So never assume that residential elevators equal exempt. Elevators are treated closer to a commercial level system. A residential elevator may be in a home, but it is not treated like a typical residential wiring. So the bottom line is, yes, you do need a permit. Next question. I hired a solar installation company to install a solar power system on my home. They are installing metal conduits on the exterior, which I find unattractive. The contractor says it cannot be removed or changed due to code requirements. Why is this conduit necessary, and can anything be done about the appearance? In many cases, the conduit routing is not just a contractor's preference. It is a part of the engineer design. If the prints show a raceway on the approved set of plans, it must be installed as designed to comply with both the permit and the inspection process. Additionally, the installation must comply with the National Electrical Code, particularly Article 690 for solar photovoltaic systems, a rapid shutdown requirements. Why the electrician is saying it cannot be changed? It's not that changes are impossible, but any changes must still comply with the National Electrical Code, Article 690's requirements. The approved engineering drawings must comply with those. The local inspections and permitting requirements. An alternative route may require, if you want to take a different route, you may ask for a revised engineered plans, a different wiring method, additional equipment, reapproval, or re-inspections. That's why contractors often stick with the original approved designs. What you can request without violating the code. Homeowners do have input, especially on workmanship and layout. You can reasonably ask for improved routing, following the soffits, the corners, or the trims. Avoid highly visible wall areas when possible. Painted conduits, things like that, but that's going to be an additional cost with materials. The practical takeaway is the conduit is usually there because it ensures electrical safety, it supports first responder protection, it helps the system pass inspections without delays. However, appearance still matters. While the conduit likely cannot be eliminated, it can often be installed in a cleaner, more intentional way that better complements the home. In today's episode, we covered real-world electrical challenges from across the industry. My goal is always the same. Identify issues early, maintain code compliance, prioritize safety, improve communication across all parties. Electrical work is complex, but with the right knowledge and collaborations, we can prevent problems before they happen. Please join me on Wednesday, April the 8th, for another informative episode where we will review safety procedures outlined in the National Electrical Code and discuss common mistakes that occur during electrical inspections. If you are a part of an organization and would like to be featured, feel free to reach out. Feel free to reach out through social media with any questions or topic ideas. You can find me on Facebook, Instagram, YouTube under the name Ask the Lady Electrical Inspector. You can also email me at asktheladyelectricalinspector@gmail.com. Thank you for tuning in. Until next time, stay compliant, stay safe, and keep the power flowing.